All right, so this is the second half of 4.1, a little factoring refresher as it says. So we've got 4 different sets, 4 different categories. So the next set, 4.2, we're gonna be solving by factoring. So this is basically just making sure that you are all brushed up on your factoring skills. So we're gonna do all the odds on these next 2 pages. So 4 different sets. Set 1 is a greatest common factor. What you're doing with these is literally just looking for something that's common between the terms, either the 2 terms, the 3 terms, and you're factoring it out. There isn't anything that you do beyond that. So for number 1, we have a 12K and we have an 18. 12 and 18 are both multiples of 6. So that's what we would write out front as our greatest common factor. And then the way that you factor it out is you put the leftovers in parentheses. So it's basically the way that distribution works, except in reverse. So it's like we are undistributing a 6 from these 2 terms. So when we get rid of a 6 here, or divide out a 6, this first term is a 2K. When we divide out a 6 with this term, we would have a -3. And that's actually as far as it can go. This right here, it's not a quadratic, it doesn't have a GCF, so there's nothing else that you could do to factor what's written right here. Next one, this one, if you look at all 3 of these terms here, 14, 35, and 7 are all multiples of 7, so I can factor that out. And then I have 6 copies of M, 3 copies, and 2 copies. So all of them have at least an M squared. So I can factor that out. So the way that works, like you said, you're kind of undistributing, and then everything else goes in parentheses. So if I divide out a 7 from 14, I have 2. And if I divide out an M squared from 6 copies, I am left with 4. So that would be M to the 4th. Then minus the next one, 35. If I take out a 7, I'm left with 5. 3 copies of M, divide out 2, I'm left with just a single copy. And the last one, -7, if I divide out a 7, I get -1. And if I divide out M squared by M squared, that doesn't leave anything behind. So this is as far as this one goes. We don't factor 4th powers. So we take out a GCF and that just stays just the way it is. Next set, trinomials. These are the more straightforward trinomials. So remember, look to see first if you have a GCF. Okay, so you should be doing that with every single problem to see if you have a GCF. If there's nothing in front of this term, then there probably isn't a GCF. So like with number 5, there's nothing that all 3 of these have in common. So with that, we just go right into our 2 sets of parentheses. We saw this a little bit at the very end of Unit 3. So our x squared, we would have x times x, which would multiply out and give us x squared. And then for these empty spots right here, these 2 numbers are supposed to multiply and give us 45. So like this times this should be 45. And my middle term is supposed to be 14, which means if I multiply these 2 values, I'm supposed to get 45. If I add these 2 values, I'm supposed to get 14. So that would be a 5 and a 9. If you multiply them, you get 45. If you add them, you get 14. That's how you know it's right. Next one. No GCF, there's nothing that all 3 of these have in common. So you go right into your factoring. Your C squared would be C times C. And then this missing constant, these values are supposed to multiply and give us a -48, and they are supposed to add up and give us a +2. So a -48 means one of them is negative and one of them is positive. So to multiply to this and add to a +2, that would be a -6 and a +8. You multiply them together, you get this. Add them together, you get this. Next is number 9. No GCF among all 3 of these terms. So we go right into factoring. A squared would be A times A. And then this, I'm supposed to multiply to a 36, and they're supposed to add up to 12. So multiplying to 36 and adding to 12 would be 6 and 6. So if you wanted, with this one, you could write it as A plus 6 squared, which is something we did at the end of Unit 3 as well. All right, number 11. There is a GCF. See how they're all even? So you can start by factoring out a 2, just like we did with numbers 1 and 3. So factor out a 2 and then see what's left in parentheses. And then this one, this didn't happen with the first couple problems, but what's left in parentheses can actually still be factored down further. So if we write this down, we have a 2 right here, and then the k squared, since it's a quadratic, we can factor it down a little bit further, and we write k times k. Then we are looking to see what values would multiply to a -20 and add up to a -8. And so one's negative, one's positive, we know that. Since the addition ended up negative, that means the bigger number must be negative. So it ends up being a -10 and a +2. They multiply to -20, they add to -8s. All right, moving on to step 3. Step 3 gets just a little bit more complicated because these values have a number a that's not just a 1, the way that 5, 9, and 7 were. So with number 13, still look for a GCF, but 2, 15, and 18 don't have anything in common. So what we do is we do a method called the slide and divide. Okay, so the slide part goes like this. The 2 from the very front multiplies by the 18 from the very end. So we remove that 2 from the front term, slide it down to the end, and multiply it by the 18. So 2 times 18 would be 36. This is like a temporary rewrite to help us factor this easily. So then you factor it just like we did up here. So like this part is pretty easy. So the x squared would be x times x. And then I am trying to multiply to 36 and add to a negative 15. Okay, so this should be a negative times a negative, because that's what would give me a 36. And the 36 would be 12 times 3, and that's what adds up to a negative 15. So we're not quite done. To finish off the slide and divide, we did the slide and then the factoring. Now we have to finish off with the divide. So whatever this number is right here that I multiplied by at first, I then have to divide both of these values by this number. Okay, so now one of two things will happen. It could reduce, like 12 over 2 reduces down, and if it does, you just leave it like this. Or it might not reduce, and if it doesn't reduce, then you slide it right back in front of the x. So the 2 slides right back in front of the x, and you have your 3 right here. So that is your final answer to factor this down. Okay, we've got a few more of these on the next page. So let's jump to 15. So slide, divide again. Look for a GCF first. 3, 19, and 40. There's nothing they all have in common. So I start with my slide. So the 3 slides down, it multiplies by the 40. So negative 40 times 3 would be a negative 120. Okay, so this, then I factor, so this would be h times h. So I am multiplying to a negative 120, and then I am supposed to be adding to a negative 19. So I know one of them is going to be negative, one of them is going to be positive. So what this ends up being, this is a little bit of a trickier one, 120, we have 24 times 5. 24 times 5 gives us 120. So it'd be a negative 24 here, and a positive 5 right here, and those add together to give me a negative 19. So that's what it would be initially, and then don't forget the divide part. So I divide by 3. So divide this by 3, divide this by 3. So this reduces. Negative 24 over 3 reduces down to 8, so I just do that. 5 over 3 does not reduce, so I slide the 3 right back. So slide it in front of the h, and then keep the 5 right here. That would be your final answer. Same process with 17 and 19, so no GCF. So we slide the 6 right over, so minus 5y. So we have 21 times 6, which would be 126, they would put right here. So we slide first and then divide. So we would have y times y gives us y squared. And then we are looking for something that multiplies to a negative 126. But would add up to a negative 5. So let me play around with a couple of values here. Okay, ends up being 9 times 14. So 9 times 14 gives us negative 126. So it'd be a negative 14 and a positive 9. So the negative times positive gives us a negative 126. And then the negative 14 plus positive 9 is what adds to this in the middle. So to simplify, divide back by this 6. Now these reduce, but not to an integer, so I'm going to reduce them. So this 14 over 6 reduces down to 7 over 3. And then the 9 over 6 reduces down to 3 over 2. So now I have to slide those numbers back out. So the 3 slides in front of the 9, and the 2 slides in front of the y. So that would be your final expression. All right, one more of these with number 19. The 9 slides. So the x squared minus 12x, the 9 slides and multiplies by the 4, and we get 36. This one we actually already factored. This one factors to x minus 6, x minus 6. And then we finish off by dividing. So divide by 9. These reduce, but not down to an integer. They reduce down to 2 over 3. So very similar to what just happened with number 17. So they reduce down there, and then the 3 slides back out front of the x, and it does that with both of these. All right, so that would be your final answer for number 19. One last set, and I think you guys might actually find these to be the most straightforward set. Difference of squares, you just have a perfect square right here, a perfect square right here. That happens for both of these terms. So x squared minus 4, here's the way it works. We still have our two sets of parentheses. The x squared is just x times x. The negative 4 is just a negative 2 times a positive 2. So these terms are almost identical, except one's negative and one's positive. And what ends up happening there is if I were to FOIL back out, my outside term would end up canceling with my inside term because they're identical except for the sign. So the one positive and one negative would end up canceling. So that's why I don't have a middle term here. So this process works the exact same way. So two sets of parentheses. So 9x squared, you sort of like take the square root and it would be 3x times 3x. And then this pattern means 1 minus 1 plus. And the 25y to the fourth would be 5y to the second, 5y to the second. And that would be that pattern. One last one here. So these aren't perfect squares. The reason they're not perfect squares yet is because this actually has a GCF. So the 72 and the 2, you can factor a 2 out from both of them. Then we have 36, whoops, not y, don't know where that came from. Sorry, r to the 6th minus just an s squared. I'm gonna try that again. Okay, so after we factor out a 2, the 2 just kind of stays out front, and then the rest of it would still be the difference of squares pattern. So two sets of parentheses. The 36r to the 6th would be 6 times 6 gives us the 36. R to the 3rd times r to the 3rd would give us the r to the 6th. And then 1 minus 1 plus for this pattern. S squared would just be s times s. And that would be your final answer. So it was a little factoring refresher for you.